Okay, this is using the powers of 10 to estimate numbers. The first thing I want you to focus on is the fact that they do give you some help up here. Step one, you're going to round to your largest number, which in this case was, if I rounded at 3 billion, it would be at 4 billion. And so I am then just going to count the digits behind it. So see how this got rounded to 4? And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So that is where this 9 came from. Okay, this one over here, I'm going to round to its largest decimal, which is this 2. So I look next door and it makes it 3, which is why they stopped right there. I'm going to count the zeros. 1, 2, 3, 4, 5, 6. But I had to count the place value. So let's talk about these that are lower than 0. Since it has to go one more space, because technically the decimal point has to go behind the 2. That's why instead of just counting the zeros, it's the zeros plus 1. Okay, so that's where this came from. So it has 7 spaces, including the 1 to move it behind the 2. Do you see that right there? And it looks like they have it written wrong. It should be 2 times 10 to the negative 7th. So you'll see that, and I'm going to zoom so that I can write better. You'll see that we have to go 1 space, 2 space, 3 space, 4 place, 5, 6, 7 in order for it to be a whole number. So that is why you need to add that extra and make it negative. All right, so let's come down here. When would you use the powers of 10 to estimate a quantity? When the numbers are very big or very small. Construct arguments. Ken writes an estimate for the number as 4 to the 10 to the third. So explain why this cannot be correct. This is not correct because the number is a decimal. The exponent should be negative. So this person rounded the big number. Those are thousands, millions, billions, trillions, maybe. So I'm going to zoom so that I can see a little better. I'll change my color, I hope. I don't want to use red, but we'll go to green. No, don't want to do that either. What is happening? I don't know. We're going to write with what we got. So I'm going to count all the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So where did they come up with 8? I agree that it's 3 times, it should have been 3 times 10 to the 11th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. So if it had been 8, then she would be rounding to here. So I'm going to confer with my book and try to figure out what she might have done wrong according to them. Because to me, she just counted wrong. But supposedly the book will go deeper, so we're going to verify. Let's see here. She miscounted the numbers of zeros. Yep, I was overthinking. The book said she miscounted the number of zeros. So let's see if I can change color. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, she just counted the zeros and ignored the first numbers that still held the place value. So maybe we'll say it is necessary. I can't spell necessary. To make sure all place values are represented. All right, let's go to number 4. Use a single digit times the power of 10 to estimate the height of Mount Everest to the nearest 10,000 feet. So I'm going to look at the biggest number and next door. So that's going to make me round this to 30,000 feet tall. So that means my decimal needs to go right here, right? So 3 times 1 0, 2 zeros, 3 zeros, 4 zeros, 10 to the 4th power feet tall. That's all they want there. You might need to put about. Sorry, the book says I need to put about. A scientist records the mass of a protein as all of that. Use a single digit times the power of 10 to estimate the mass. So we're going to put our decimal right here. See it? So I have to round that. I'm going to change this to a 2. Let's see if I can make sure you see what I'm doing. I'm rounding this to 2 because my decimal goes there. So it'll be 2 times. Now I've got to count my zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and I need to give it the extra one so that it goes back here, 24. So 10 to the negative 24th power. Checking the book, make sure I'm right. Yep, and we're going to put about, because these are all estimates, grams. Ta-da! The tanks at the Georgia Aquarium hold approximately 8.4 times 10 to the 6 gallons of water. The tanks at the Audubon Aquarium, they held about 4,000. Use a single digit times the power of 10 to estimate how many times greater the amount of water is at the Georgia Aquarium. Okay, so I'm going to do what I think we're supposed to do here because the book is not giving me too much to go on. Why do I keep pushing those buttons? So I want to make this. I need to look at both numbers. So this is 8, 4. So that's 1 place value. We need 5 more zeros. 1, 2, 3, 4, 5, right? So if I go 1, 2, 3, 4, 5, 6, yep, that is correct. So I'm verifying currently. That's what I was doing. And the other one says 400,000. So let's line those up. So it says 8. I get it. But only because I'm looking at what the book says. So what the book is telling me to do is round this one. So this one is about 8 times 10 to the 6th. Okay. This one is about 4 times 10 to the 1, 2, 3, 4, 5, 5th power. Okay. So we're going to divide these two numbers and divide these two numbers. So it's a division problem. That's why I put that line there. Let's see if I can erase this because we're guessing how many times. So technically it's a division problem, which I would struggle with as well. So 8 divided by 4 is 2. But these two numbers, we're going to use our rules. So since they are dividing, correct, that means 10 to the 6 minus 5, which would mean that ours is 2 times 10 to the 1st power greater. Now, process that to make it make sense to you. But if I said something was 8 gallons, I can't write, 8 gallons, and the other one is 4 gallons, and ignored all the other stuff, about how many times is one than the other, I divided them. So that's where that came from and where my brain had to go. So this is just kind of introducing the topic, making sure that you see what the book is going to expect on some of these homework problems.